Okay, let's just dive right into this explainer because we really need to address that giant, overwhelming wall of decisions that literally every aspiring software engineer hits right at the starting line. You've decided you want to build software, which is absolutely fantastic, but then you hit the search engines and suddenly you are just bombarded. Should you learn Python or JavaScript? Are you supposed to be a front-end developer, or is backend where the real money actually is? What about full stack? Or should you just jump straight into AI and mobile development? It is incredibly overwhelming, and it can leave you totally frozen in analysis paralysis before you've even written a single line of code. You're always going to hear people say, just learn whatever you enjoy. But honestly, that is completely useless advice when you're just starting out. I mean, how can you possibly know what you enjoy when you don't even know what the daily reality, the specific challenges, or the job market of these different paths actually look like yet? You need real, concrete context, not vague platitudes. So, we're going to clear up that analysis paralysis today with this definitive roadmap. We'll start with the big picture, check out a day in the life of front-end and back-end roles, explore the full-stack advantage, dive into some niche roles, and finally outline your exact first steps. Let's kick things off with Section 1, the big picture, and how software actually gets built. To make all these specializations make sense, think about an app you use all the time, like Instagram, for example. There are two totally different but deeply connected sides to it. First, we have the front end. The front end is your user interface. It's literally everything you see and interact with when you physically tap, click, or scroll. The photos, the layout, the sleek animations, the shape of the buttons, that is all front-end engineering. And it's running locally, right there on your mobile device or inside your web browser. It's the face of the application. But when you actually look at a photo and hit that little heart icon to like it, you're firing up what we call the invisible engine, the backend. Your front end is actually sending a request out into the void. The backend is the massive system of servers that catches that request. It checks who you are, validates that you're actually allowed to like that post, registers the action, and then sends a response right back to your phone. It's everything happening entirely behind the scenes. And to make sure that invisible engine actually remembers anything, we have the database. This is the core storage system where all the application's data permanently lives. Your user profile, your history of posts, your list of followers, that's all securely held in a database. Backend engineers work intimately with these to ensure your data is stored safely and can be fetched in a fraction of a second. All right, zooming in, let's look at Section 2, a day in frontend, building the visual interface. So the whole point of front-end engineering is taking core web foundations like HTML, CSS, and JavaScript or TypeScript and turning them into visual, interactive software. If you're a super visual person who gets genuine satisfaction from creating a polished, tangible product, this is definitely where you want to be. And to do this efficiently, you aren't just writing raw code from scratch. You'll likely use React. It is a massive industry standard in 2026 for building user interfaces. Sure, there are other great frameworks like Vue and Angular, but mastering React consistently makes front-end developers some of the absolute most sought-after engineers on the market. A typical day here tells a very visual story. You'll usually start off by getting a design file or a mockup, probably built in Figma by a UI designer. Your job is to translate that static picture into reality. You write your code, constantly refresh your browser, and you actually get to see your work come to life immediately. You're tweaking layouts, managing interactive states, and making sure that what you build is a pixel-accurate representation of the designer's vision, one that works flawlessly on both a giant desktop monitor and a tiny smartphone screen. So what are the realities of this job? Well, the immediate visual feedback is a huge pro, and the overall job demand is incredibly solid. Historically, front-end paid a bit less than back-end, but that salary gap has narrowed significantly in recent years. But here's the major gotcha. The front-end landscape moves incredibly fast. Frameworks evolve, new libraries pop up constantly, and you have to be really comfortable with nonstop change. Plus, ensuring your interface is perfectly responsive across thousands of different device sizes and completely accessible to users with disabilities can be a ridiculously challenging puzzle. Now, let's flip the script and move to Section 3, a day in backend, building the invisible engine. If you're the kind of person who doesn't care if things look pretty, but you love systems thinking and figuring out how things work under the hood, this is for you. Over here, you have a totally different toolkit. You'll often be working with languages like Python, Java, or Node.js. Python in particular is highly common and incredibly versatile for new backend developers, frequently paired with frameworks like Django or FastAPI to help you spin up servers and connect complex systems together securely. Your daily narrative here is way more analytical. You're definitely not staring at Figma designs all day. Instead, your morning might involve designing the actual architecture of a database schema, figuring out exactly how user data maps to post data. Then you're building the API endpoints, which are basically the specific doorways the front end will call to get that information. And all day long, you're enforcing business rules, validating data, and making sure the entire system is both crazy fast and totally locked down for security. The major payoff for backend work is extreme market demand, especially if you get into cloud architectures and microservices. Because this work is so critical, it typically commands higher starting salaries. But there is a real trade-off. Your work is entirely invisible to the end user. Your friends won't be able to see what you actually did at work today. On top of that, you're going to be tackling much harder, thornier debugging puzzles. Trying to track down a concurrency bug where two different users try to update the exact same piece of data at the exact same millisecond. Yeah, that is an incredibly complex headache. But what if you literally can't decide? What if you want the visual satisfaction of the front end, but you still crave the analytical deep dive of the back end? That brings us to Section 4, the full stack advantage, combining both worlds. Basically, full stack engineering means you handle both. You take total ownership of a feature from the deepest part of the database all the way to the user's screen. As you can see in this breakdown, each path has its own distinct challenges. Front-end tests how well you adapt to fast-changing tools. Back-end tests your logic against serious data and security bugs. Full-stack engineers, they have to absorb the gotchas of both sides. The unique difficulty of full-stack is the constant context switching and carrying a very broad system responsibility. But the advantage is massive. It makes you incredibly hireable, especially at startups, because you can just evolve and go deep wherever the job demands it on any given day. Okay, moving quickly onto Section 5, niche roles. Let's talk mobile, cloud, and data. Once you have a foundation, you can branch out into some wildly lucrative specialized paths. The job market here is incredible right now. If you love mobile products, learning iOS with Swift or Android with Kotlin is a fantastic move because literally every company needs a native app. Then there's data and machine learning engineering, driven by the booming AI wave. If you're really strong in math, statistics, and Python, this is super lucrative. And finally, there's DevOps and cloud engineering, which focuses entirely on infrastructure and automation. I really want to highlight that last one because it's vital. Cloud infrastructure refers to the underlying systems, stuff like AWS, Docker, and Kubernetes, that keeps software running smoothly, deployed automatically, and perfectly reliable. If you love infrastructure puzzles and building the literal pipelines that keep the internet alive, DevOps is a deeply satisfying and exceptionally well-paid field that is almost always overlooked by beginners. So we've mapped out the entire landscape, which leads us to Section 6, your first steps, ending analysis paralysis. How do you actually start from scratch today with the most career stability? Well, if we compare paths side by side for a total beginner, choosing a highly specialized niche like machine learning or embedded systems right out of the gate is actually pretty risky. It narrows your job pool drastically before you even have any real experience. On the flip side, starting with full-stack web development wins outright. It makes you broadly hireable from day one, there is a massive ocean of learning resources out there, and most importantly, it gives you the overall context of how software works so you can easily pivot later on. So here is your exact, definitive learning order to build that rock-solid foundation. Step 1, commit to full-stack web. Step 2, learn JavaScript or TypeScript and master React for your front-end visual interface. Step 3, add a backend language, either Node.js to stick with JavaScript or Python to build your invisible engine. Step 4, get hired, evolve, and specialize on the job as you gain professional experience and figure out which side of the stack you actually enjoy more. Your analysis paralysis officially ends today. The skills you learn in any of these domains will transfer way more than you think, so the most crucial step is to just start building. So, what's it going to be? Are you drawn to the invisible engine of the backend or the visual interface of the front end? Drop us a comment with the specialization you're leaning toward right now, and get ready because you are definitely going to want to dive into computer science fundamentals and what you actually need to know in our next explainer. We'll see you then.